Hello guys, and welcome back. And welcome back to a new video on a new topic. And this time we're going to be talking about this little device. This is an ESP32. I think it's a vroom, something like that. Anyway, what I'm doing here is I have this hooked up along with some of these things, which are temperature sensors. So you see I have them all wired up there, and I have set this up in such a way that it broadcasts the temperature read by these three sensors onto a web browser. And as you can see, it's coming up on my phone. It's showing at the moment the temperature read by those sensors is around 17.5 degrees, something like that. They're all slightly different. They're not the most accurate things in the world, I don't think, but that could be down to bad connections, I'm not sure. But basically what I'm doing here is I'm trying to send three different temperatures in such a way that it can be read by my mobile phone anywhere in the house. Now, why would I want to do that, you ask? A common question that I get multiple times per week is, Dad, is there any hot water? Normally the answer to that is, I don't know. You need to go and put your hand on the pipe and feel it and see if there's hot water. Doesn't matter how often I say that, I still get asked the same question, Dad, is there any hot water? So what I plan to do is to take these three sensors, solder them onto a length of wire, sticky tape them to the hot water tank so that I can at a glance tell immediately what the temperature situation is in the hot water tank. And the reason the family used the hot water in the hot water tank for showering. Now normally that water is heated during the summer particularly by solar, and in the winter normally just heated by a central heating system that we have. It's an burning oil-fired central heating system. So that's what this is all about. The reason I'm doing it, and the reason I wanted to do it, is because once I get this operational in the house, I can then transfer the exact same situation into my electric car, and I can have multiple temperature sensors in the car, basically all being read by the same device, and all of the temperatures broadcast live, real time. And that means all I need then is something like a mobile phone connected to it, and I've got an easy way to keep an eye on the temperatures in the car. So that was the reason for doing this. The temperature sensors I will be using in the car will be slightly different. These are Dallas DS18B20 temperature sensors. Now you can buy these as you can see them, just they're I can't remember the name for that shape of device, but there's a TO2, something like that, I can't remember. But you can also buy them basically as a little sealed unit that is pretty much waterproof. So that was the reason why I wanted to do this. Setting it up for the hot water tank was basically just a way of learning how to do this so that I could then do the same thing in my electric car. Now, one thing I need to tell you is I am not an expert in any way, shape or form. I had to learn all of this stuff. I managed to just do this by basically plagiarizing, copying, and other people's work. I couldn't program to save myself. But it works. That's the main thing. So now I'll show you how I did it. Right guys, well as you can see, this is more or less where I started. A couple of months ago I saw this web page, or it may not have been exactly this one, but it was one with the same idea, where it was telling you how to use an ESP32 with a BME280, and it takes you through the whole process for how to do it, how to wire it up, and how to use this particular device to create, in this case, temperature and pressure, I think, and a few different things. But anyway, first step I had to do was to order some of these. So what I did was I went on to AliExpress And I ordered some of these, which, as you can see, if we can get it to focus, yep, looks like the same device, doesn't it? Except it was only after I spent several hours playing with it I realized this is not the same. What I bought is not a BME280. What I bought is a BMP280, which is a different device entirely and doesn't work with any of this software. So at that point I went, oh. I was also struggling to work out a way of, even if I did have the correct device, to have several of them, like 3 or 4, all giving temperatures all at the same time. So what I did was, I looked around for a bit more and I came across this. ESP32 with multiple DS18B20 temperature sensors. Now that is exactly what I wanted. It's exactly what I was trying to achieve. So I used this plan to build a system that would give me multiple temperatures. Now that was all very well. The only problem with this is it's not on Wi-Fi. The other one, on the other hand, is on Wi-Fi. So what I then had to do was spend several more hours working out how to basically transfer the stuff from the non-Wi-Fi onto the Wi-Fi so that it would broadcast the whole thing on Wi-Fi. So what I did was, bring them down like that, I brought up the two programs. I started copying and pasting stuff from one to the other until I came up with this. And this is the program, which is, as you can see, Mr. Rui Santos created this, and I adjusted it to give me what it was I was trying to achieve. Now what I'll do is I'll post a link to this program down in the comments below. So if you're interested in doing something similar, you'll be able to copy it. I'll also post a link to these two web pages, so you can go in and see how it was actually achieved in the first place. There's no point in me trying to redo what has already been done here. It's done extremely well. There's no way I could do it as well as this. So that would basically give you the idea of how to create what I've done. Now what I would need to say is there was a few gotchas. Basically each of these little devices has an address, and the first thing you have to do is to find out what the address of each of these is. So to do that you have to wire it up with basically the same as this, but up here it talks about wiring into digital pin 15, and down here it doesn't implicitly say it, but it does mention it in this part of the software that it's actually on pin 4. So in order for you to get the address, you either need to change that to pin 15 or rewire your device to pin 4, to digital pin 4. So what you do is connect this up, connect the little temperature sensors in one at a time, the way this is set up here, and then come down to this software, change it to pin 4 or change that to 15, run this, and then when you look in your serial monitor you should see ROM equals, and it'll give you the number. Now if you have all three of them plugged in the way it was in the bit above, it'll give you all three of the addresses for each one of those three devices. So what you then, that's why I'm saying if you do them one at a time, it's easier to figure out which one it is. You have to take a note of all of these numbers, because each of those is the individual address for the individual temperature sensor that you're about to use. And wired up as it was before, and then when it comes to the full software for the device, you have to put in the numbers that you have just collected These are not the numbers you're going to be using. You're going to be using the numbers that you collected at this stage. So put those numbers in, and with any luck you should then start to see something like this on your serial monitor. So once you've done that, that will give you the simple setup where the temperatures are just being shown in the serial monitor, but that doesn't give you the Wi-Fi. If you want to have the Wi-Fi, you then have to go to this and install these different libraries. Copy this setup, and that will give you the setup that I've got in my phone, that you can see on my phone. So that's how I did it. Like I say, I'll post a copy of this in the description below, or a link to it. I'll put this up on GitHub so you can get a link to it. And yeah, you can do it yourself and see what you think. If you can improve it, that'll be even better. Now, if I was to put my finger onto one of those temperature sensors, you won't see anything changing, because you need to refresh your phone for that to work. And as you can see, one has gone up to 22, and that was just from me putting my finger on the temperature sensor. And now that I've removed my finger, it should start dropping back down again, down to 20. Yeah, it's going down to 19. There you go, temperature's fallen. So it is quite fast to react, but it does mean that you have to refresh your phone every time. Possibly if I knew anything at all about HTML, I could make that it went continuous, continually updated, but I don't care sufficiently. For monitoring temperatures in the car, I will need to change that so that it continually refreshes, but that's for the future, and this is working well enough for me for now. So my next step is to take these temperature sensors, solder them onto bits of wire, create some sort of a cradle for the ESP32 or some sort of a box and power supply for it, and put it into my hot press. Right guys, well, as you can see, we have the temperature sensors soldered onto just a piece of old Cat5 cable, and just so that I can identify which is which, I've given each one a different colour. Orange is the pause, orange and white is the neg on all of them. Brown, blue and green are the sense wires, and like I say, that's just so that I can say that brown is bottom, blue is middle and green is top. And over here they're all connected. Obviously I could have used the same colour for all of them, it wouldn't have mattered, because they're all going back to the same sense pin on the ESP32, but they're all going through this resistor. You can see in there, they're all going, basically they're all connected through that resistor into the ESP32 pin 15. And on the screen, as you can see, I've just decided to put it up on the big screen. It is coming up, temperatures are showing correct. Now, if I was to say remove the brown wire, which should disconnect the bottom, and then refresh the screen, it comes up with -127, so that's okay. That tells me there's a bad connection there. Well, as you can see guys, we have managed to get this ESP32 soldered onto some Vero board. Now unfortunately it's the type of Vero board which has individual solder pads, which means to create a bridge you either have to use a piece of wire or some very ugly soldering, as you can see, but it's working. It's not pretty, but it works. And I'm currently driving it off a standard lithium ion battery. This is a I think 2000 ampere hour battery, something like that, 1800 milliampere hour battery. So I suspect running it off this will last maybe 25 hours, something like that. It's currently drawing approximately 70 milliamps. Now it'd be nice to be able to reduce that current draw, but it's not really terribly high on my priority list right now. I just want to get this installed in the hot water tank so that each of the sensors is actually touching the copper of the tank. So I'll have to scrape away some insulation to do that. Our hot water tank has a foam insulation covering it. So anyway, this, as you can see, it's working. There is the result. And if I refresh the screen, yeah, we're still getting 17.8 degrees centigrade. Not particularly warm in the house today, but it's a very cold day outside. And we don't tend to run the central heating during the day very much. Okay guys, so this is the hot tank. And I now have the sensors placed, one about here, one about here, and one about here. And as you can see, I've just very roughly taped it into position. And temperatures we are getting are as shown as follows. I'll just refresh that. 50 degrees for the top one, 36 in the middle, and 23 at the bottom. And what we really need is for enough hot water for probably 2 showers, we would need the middle one to be closer to 50. I'm not sure yet, I've only just installed this, so I don't really know for sure what the temperatures need to be, but I'm guessing just from normally if I put my finger on there to feel the temperature, it seems to be around about what I would have considered enough for 1 shower in the past. And just in case you're wondering, this is the device that gives us hot water from the solar. It's called a solar eye boost. If I push the button, so far today we have saved 2.39 kilowatt hours, which is not going to give a full tank of hot water. I think a full tank is around about 6 kilowatt hours, but that's enough to give a shower. It's certainly enough to save maybe half a litre, between half a litre and a litre of oil, which is what we use to heat the hot water tank. So as you can see guys, a couple of things have changed here. The first is that obviously the single battery that I had was too small to drive this, and I decided that since I had a couple of these lying around, which are 3S by 6S by 3P battery modules, battery packs that I built years ago for some project or other. These are around about 12 volts when they're fully charged, 12.3, something like that. And I decided to use these to drive this little device, not because there's no power available locally for it. There is a socket that I could use, but I just fancied the idea of running this off a battery and then charging the battery during the day, which means it's being charged by solar, which basically means this would be as far as power is concerned, it would be a free project. It wouldn't actually draw any electricity at all. So that was the first thing. Like I say, I had these lying around. I have 2 of them. So they are 12 volt batteries, and they'll probably last for about a week before they need charged again. So that's good. The other thing I did was, because I'm running off a 12 volt battery, I decided to use a buck converter, a DC to DC buck converter. Probably not entirely necessary, as these are happy enough running off 12 volts. But I just thought, the voltage regulator might struggle a little, so I thought we'll just use a little buck converter to bring it down to 5 volts. So that's all nice and neatly installed, and as you can see, I have it in it's a little plastic container that would normally house something like this, an Arduino Uno. So that's that. The other thing that I had to do was to change the software. Now, the software I showed you is basically this, and this is, it works very well, but it unfortunately disconnects from the network on a regular basis, so I had to keep resetting the little ESP32, pushing the reset button or powering it off and on again to get it to reconnect. So that became a bit of a drag. So what I did was, like I said before, I'm hopeless at programming. So what I did was I took this sketch and I basically selected it all and copied it, and then I went to somewhere I'd never been before, and this is called ChatGPT. You've probably heard of it. It's artificial intelligence created by OpenAI, and what I did was I started a new chat like this, and went down to here to where the new chat is, and I typed in, please, if you can spell, please optimize the following code to prevent to auto reconnect to Wi-Fi. Now, I can never spell, never have been able to spell, and yeah, there's evidence. Anyway, it may have not been exactly like that, but it was something like that. I then held the shift key and hit return, and I pasted the code and told it to go ahead and do it. And after a period of time, it seems to be very slow thinking about it, it started to regenerate the code. Oh, there it goes, regenerating the code. Now, what I did find is that it stopped halfway through more than once, and I ended up having to put the code in chunks and get it through bits at a time, sort of in smaller chunks. This ChatGPT thing seems to be okay most of the time, but it can be a bit flaky. And it stops. Yeah, that's it. It's gone so far and then just quit. I heard somewhere that if you type continue it'll carry on, but I'm not sure that that's true. Is it true? Didn't work for me the last time I tried it. Maybe, I'm not sure. That might be correct. But at least it gives you an idea of what ChatGPT is able to do as well. Oh, by the way, don't expect the code to be perfect if you do this. More than once I got it to generate code, which I then got it to debug, and actually it was full of bugs, just straight from what it had created. The other thing I found is that sometimes the information that you've put into it, like for instance the particular connection you're going through, in this case 15, GPIO pin 15, or maybe the device addresses for the sensors, sometimes you can actually change those without warning, or the connection to the Wi-Fi can be changed without warning. So you need to be kind of careful to not necessarily just take everything for gospel that this thing says. It does make changes, it does do things that you don't necessarily expect, and this code which it has generated is completely different to the code it generated last time. So you're not necessarily going to get the same thing or the same results every time you use it. In fact, I guarantee you, you will not get the same results every time you use it. But it can save you a lot of work trying to figure out how to do these things. I'm not a coder. I don't know what I'm doing here. I'm just making it up as I go along. And if I can get it to work, that's good enough for me. It doesn't have to be pretty. So like I said, after a few false starts and a few issues and whatever, this is the code that ChatGPT finally came up with. And as you can see, it's quite a bit different from the original code that was created, but it does work. It works very well. This is the output on my phone, and it looks slightly different, but it's fine. It's doing the job that I asked it to do, and it's stable. This has been running now for a couple of days. I haven't needed to go near the ESP32, so it seems to be running very well. So I'm very happy with the result. And like I said earlier, I will have to make changes to use this in my electric car project. I'll obviously need to have the code refreshing on a regular basis, because I don't want this is for early warning of problems with temperatures in the car, and obviously if I have to refresh the screen every time, that's not much good. But also this is running on my Wi-Fi in the house, and if I'm out in the car I'll not have Wi-Fi, so I'll have to have this running as a standalone web server, but that's okay. That's fairly simple to achieve, and I've even asked ChatGPT to do that, and it's made relevant changes to achieve that. So all of that is doable. Even for a non-coder like me, I can use this system to generate code that does actually work. You do have to do some bug finding and fault finding and making changes and so on, but in general it works well enough for a non-coder like me to be able to get things working as I need them. So hopefully this has been of interest to you and of help. There are links in the description below, video description below, so if you want to go down and take a look at those, to the various bits of hardware that I've used, and also to the GitHub where you can download this code if you are interested in doing something similar, and also to the web pages that I was showing you before. Really excellent tutorials, and well written and entertaining, and definitely worth going to take a look. So anyway, hopefully this has been interesting, and thanks for watching. Bye for now.